All right, welcome back. Okay, for half angle, right? You can see we have come a long journey, right? From this piece, we got the rest, right? And we've done all the double angles. So now we come to the place of half angle. So what we're going to do is we're going to start from here and work out the half angle. Okay, so let's begin. Right? So we have these two formula. That's what we're going to start with. We're going to work on the half angle. Okay, so our goal is to work out the half angle formula. We can start from here. Okay. We can start from there. Okay, from these two, from these two. So half angle formula from these two. Okay, so watch out for the observation. Okay, from these two, we're going to introduce some substitutions. Okay, we're going to assume that theta is equals to half of alpha divided by 2. So this alpha, oh wait, no, we're going to do alpha, my bad. Alpha equals to 2 times theta. Okay, alpha is 2 times theta. And how do we do this? I want this to be half angle. Let's do this. Theta divided by 2. What am I doing? Okay, alpha equals theta divided by 2, right? So here we go. If alpha equals theta divided by 2, we're going to replace alpha by theta. There. All the alpha is replaced by theta. See that? All the alpha replaced by theta. That substitution is done. To simplify, we got the next. Okay, 2 times theta over 2, that's just going to be theta. And so this piece is theta as well. So here we go, we got the half angle. We're almost there. We're almost there. And next, we're going to take square root. We're going to take square root. Okay, so let's do one at a time. So for this piece, we're going to take square root on both sides. Okay. On the left-hand side, it's going to be absolute value of cosine theta over 2. On the other side, it's going to be the same. And then cosine theta over 2 is equal to plus minus of that. So we get one of the half angles. Okay, so we got one of the half angles. Okay, so we're going to put a half angle right here alongside with all the other formula, one of the half angles. Okay, and then we work similarly on this piece. Okay, and we're going to take square root on both sides. Take square root on both sides. And here we go. On the left-hand side, it's absolute value sine of theta over 2. On the right side is the square root of this piece. Okay, so we have this absolute value equation. So sine theta over 2 is equal to plus minus of this root. So this is the, okay. So this is the second piece of half angle, right? Second piece of half angle. We're good. Well, what comes next is tangent half angle. Okay, tangent half angle. For tangent half angle, right? If we have cosine half angle, sine half angle, then cosecant and secant half angle are easy to find. And we just need to have tangent half angle, right? So let's look at what do we do for, again, to get a tangent half angle. And we understand that tangent half angle theta over 2 would equals to sine theta over 2 divided by cosine theta over 2, right? And then we got these over that. Now, question. Can we cross out the plus minus so we get a plus? Can we do that? The answer is no. The answer is no. Okay, because this plus minus and this is plus minus, there are actually 4 cases. There are actually 4 cases. So what are these 4 cases? These 4 cases, it could be a plus divided by plus. Okay, it could be a plus divided by minus. It could also be a minus divided by plus. It could also be a minus divided by a minus. So even though we have plus minus, that really indicate there are 4 cases that are possible. Therefore, we cannot cross out these 2. Okay, as a result, the final answer for tangent half theta would just be equals to plus minus, okay, root 1 minus cosine theta divided by 1 plus cosine theta in the square root. Then you say, what happened to the square root of 2? They're just reduced. So tangent half theta equals to that guy. It can also be written alternatively as just 1 root and 1 minus cosine theta over 1 plus cosine theta. Okay, all right. So next, so this is one of the forms. This is one of the forms for tangent half theta. This is one of the forms for tangent half theta. Okay, let's see, where do I put them? Over here. Over here. So let me start a new row. Okay, tangent, right? So this is one of the forms. There are 2 other alternative forms. There are 2 other alternative forms. Okay, so from this form, either one, okay, suppose I take this one. We want to derive 2 other forms. Okay, so you've got to watch very carefully here. We're going to have some interesting analysis. Okay, suppose I want to rationalize it. Okay, one way is to rationalize the numerator, and the other way is to rationalize the denominator. So suppose I'm going to rationalize the denominator. Okay, so I'm going to take, I still have the plus minus, right? Multiply. I'm going to multiply by 1. This piece, okay, that's 1. And that equals to, we still have the plus minus. The denominator times the denominator, it would just be equals to 1 plus cosine theta. On the top, right? Because the bottom is easy, 1 plus cosine theta times 1 plus cosine theta. And cosine theta is between -1 and 1. So the denominator, make sure it's not 0, right? So we're fine. On the top, inside the square root, is going to be 1 minus cosine squared theta. So what do we used here? Okay, so what do we have used here is 1 minus cosine theta multiply 1 plus cosine theta. Okay, and your FOIL, you're going to get 1 minus cosine squared theta. Okay, so that's how we get the top. That's how we get the top. Now, the question is, what will be the top be, right? On the top, we obviously get sine squared theta, right? And what is more, we're gonna get sine theta, right? We're gonna get sine theta in absolute value. Sine theta in absolute value. And then it comes to discussion. So what will happen if we have sine theta and plus minus, right? Sine theta plus minus. So we're going to have the following discussion. Now, if theta is in the first quadrant, okay? If theta is in the first quadrant, theta in the first quadrant means what? Theta is less than pi over 2. Pi over 2. If theta is in the first quadrant, theta over 2 is going to be, theta over 2 is also going to be in the first quadrant, right? It's going to be in pi over 4. So theta over 2 is in the first quadrant. If theta over 2 is in the first quadrant, it would be, this will be true, plus minus will be choosing the plus, right? We'll be choosing the plus, right? Plus minus will choose the plus. At the same time, because theta is in the first quadrant, sine theta is positive, right? Sine theta is positive, the absolute value of positive is the same at the quadrant. So that's equals to sine theta over 1 plus cosine theta. Okay, so this is the case that theta is in the first quadrant. And what if theta is in the second quadrant, right? If theta is in the second quadrant, right? If theta is in the second quadrant, that means theta is larger than pi over 2 and less than pi. right? As a result, half theta is going to be what? It's going to be between pi over 4 and less than pi over 2, right? So if theta is the second quadrant, half theta will be, so that is to say, i.e., half theta is going to be in the first quadrant, right? That's first quadrant. If half theta is in the first quadrant, tangent theta over 2, right? Tangent half theta, that's going to be a positive sign. So this piece, we will choose a positive sign. We'll choose a positive sign. Tangent theta in the second quadrant is positive, absolute value positive. So that's still the same, right? So now look at if theta is in the third quadrant. If theta is in the third quadrant, what does that mean? It means theta is greater than pi, smaller than 3 pi over 2. And this means that theta over 2 is going to be in the second quadrant, right? So this is going to be pi over 2 less than 3 pi over 4. 3 pi over 4. i.e. that theta over 2, this is in the second quadrant. So theta over 2 is in the second quadrant. Terminates in the second quadrant. Okay, so tangent theta over 2 in this case, because theta over 2 is in the second quadrant, tangent in the second quadrant is negative. So this time we choose a negative sign. Okay, tangent is in it's a negative sign, but theta is in the third quadrant. Sine in the third quadrant is negative. So sine theta is negative. So when we take absolute value, so this is going to be negative. So now we had a negative or multiply negative. So in the end, we still get sine theta over 1 plus cosine theta. Okay. So last case, if theta terminates in the fourth quadrant, okay, in this case, which means theta is between 3 pi over 2, right, and less than 2 pi. And where will what will be the half theta? Half theta will be in 3 pi over, will be 3 pi over 4 less than half theta less than pi. And this is to say, i.e., half theta is in quadrant, right? Which quadrant is this? This is a quadrant number 2. This is a quadrant 2. So half theta terminate in quadrant 2. Okay. Three pi over 4, between 3 pi over 4 and pi, right? That's quadrant number 2. All right. Is that clear? Make sure you actually follow me by taking notes. If necessary, you just take, pause it, right? Take a break or something like that. All right. So half theta is in the second quadrant. So tangent in this case because half theta is in the second quadrant. Tangent is the second quadrant, is negative. But theta is in the fourth quadrant, right? Theta in the fourth quadrant. Sorry, this is theta. Sorry, theta. Theta in the fourth quadrant. Sine theta is negative. Therefore, absolute value of sine theta is negative sine theta. The absolute value of negative is its opposite. So once again, we get the same answer. So in all four cases, right? Whether terminal terminates the first quadrant, second quadrant, third quadrant, fourth quadrant, we get the same thing. We get the same thing. Okay, so this is the third form. This is probably the second form, wait. This is the second form for tangent half angle. Where did I put it? Tangent half angle. Here. So tangent half angle like this, you can see there's no longer positive sign, negative sign. Okay, do we have a third form? Yes, we do. Okay, yes, we do. Okay, so let's go back. We just simplify, we just rationalize the denominator. What if we rationalize the numerator? So we start from the same place. Okay. And this time, okay, last time, let me write it down here. Okay, we rationalize the denominator. And this time, we're going to rationalize the numerator to see what we get. Okay, this time is numerator. Okay, so how do we do that? We're going to multiply 1 again, but this time we choose the numerator to multiply the top and bottom by. So we multiply by 1. Okay, so as a result, the top, so we still have plus minus the bottom. The bottom, we're getting 1 minus cosine squared of theta for the same reason. On the top, it's just 1 minus cosine theta. Okay, so the top and bottom taken care of. And this time, wait. Okay, and this time the bottom is equals to, of course, sine squared theta in square root. Wait. Okay, in square root. Okay, and of course the bottom is equals to the absolute value of sine theta. So we're going to fall into the same discussion. Okay, quadrant 1, quadrant 2, quadrant 3, quadrant 4, just like we did here. Okay, quadrant 1, right? Quadrant 2. Okay, I just want you to see the similarity. And this discussion and narrative are similar, but there's still a little bit differences. Okay, there's still a little bit differences. So I'm just going to take those 4 cases. So we do this again. Okay, if you want to be a little bit ahead of me to do that discussion, feel free to do that. Okay, so we get tangent theta over 2 equals to that guy. So next we're going to discuss the 4 cases. If theta in the first quadrant, that means theta between 0 to pi over 2, half theta is also in the first quadrant. So in this case, tangent half theta because half theta is in the first quadrant, so this is going to be positive. And sine theta is positive in the first quadrant, right? So the absolute value positive is the same as sine theta, because sine theta itself is positive in the first quadrant. In the second quadrant, okay, theta over 2 is in the first quadrant. So this is still positive. Positive can be omitted. Sine theta is in the second quadrant, but sine theta is the positive in the first quadrant. The absolute value positive is the same as the positive number. Okay. Third quadrant, tangent theta over 2. Since theta is in the third quadrant, half theta is in the second quadrant. In the second quadrant, tangent theta over 2 is negative. But sine theta, okay, when theta is in the third quadrant, sine theta is negative. The absolute value of negative is its opposite. So we ended up with negative divided by negative. So in the end, we get 1 minus cosine theta divided by sine theta. Last case, same thing. Okay. In the last case, when theta is in the fourth quadrant, theta is in the fourth quadrant between pi over 3 and 2 pi, half theta is in the second quadrant. Since theta over 2 in the second quadrant, plus minus, we're going to choose negative. Sine theta in the fourth quadrant, so sine theta is negative. The absolute value of negative is its opposite. So once again, we get the same answer because the negative and this negative reduced. So in all four cases, okay, we get tangent theta over 2 equals to 1 minus cosine theta divided by sine theta. So this is the third form. Where did I put it? Beneath it. There. Okay. And I shall put it in, it doesn't allow me to add a column. So let me add a column to make them, put them together. Right, so these two, we put them here. And the last one, we put it over here. So by this time, we have proved all of the identities. As you can see, they're not super difficult, aren't they? And we see that tangent half angle has 3 forms. From that 3 form, you can tell which one is more desirable, right? Which one is more desirable? Well, in this case, you have to identify the terminal of theta over 2 from whatever information is given. So if it's in the first quadrant, it's positive. In the second quadrant, is negative. Third quadrant, positive. Fourth quadrant is negative. It can be done. But if you take either one of these 2 forms, okay, either one of these 2 forms, you don't have to deal with plus minus. But there's also pros and cons. If you use the first formula, even though you have to determine whether it's plus or minus, you only need a cosine theta. But in these other cases, you have to know sine theta and cosine theta. You need to know 2 other quantities. So by this time, we have proved all of the identities in the diagram. Here we go. We have proved them all, okay? And I totally believe that you can do it too. If you do it, if you do them all by yourself, you will realize you very soon you'll find out you don't have to memorize any one of them. You can just derive them by yourself when you need them. And you also will improve your algebraic skill greatly. So it is my hope that you will make the effort to derive all of these identities. And if you have any questions, please don't hesitate to reach out to me. And in the following lessons this week, I will show you some examples of applying these identities. So make sure you have this diagram available very easily. You have it easily accessible. It's on Canvas, on top of, on the top of week number 7. Thank you for watching.